We are continuing our video on the standard normal distribution, and we are reminding ourselves again of the empirical rule. The empirical rule indicates that for a normal distribution, 68% of the data is within one standard deviation from the mean, and that will be this part of the curve will contain approximately 2/3 of the data, more than 2/3 of the data. And then 95% of the data is within 2 standard deviations from the mean. The area under the curve from mu minus 2 sigma to the area under the curve mu plus 2 sigma will be equal to 95%. And then 99.7% of the data is between negative mu minus 3 sigma and mu plus 3 sigma. I want to remind you that in the OpenStax book, we are in section 6.1, and we are continuing from the empirical rule, which states exactly what we just said. Now let's do a couple of examples regarding z-scores and the empirical rule. We have Jerome's points scored per game, and this is a variable. So the variable is the number of points per game that Jerome scores. And these are normally distributed with a mean of 16 and a standard deviation of 4. So the variable x follows a normal distribution with a mean of 16 and a standard deviation of 4. And let's suppose that Jerome last time scored 10 points in the game. What is the z-score? So the z-score will be, if you don't remember the formula is provided in our formula packet for the midterm, and it is right here. Z equals the value of x minus the mean divided by the standard deviation. So the value of x is 10 minus the mean, which is 16, divided by the standard deviation, which is 4. This is negative 6 divided by 4, which is equal to negative 1.5. And to interpret this means that Jerome's score is 1.5 standard deviations away from the mean, but it is negative, so this is below the mean or to the left of the mean. The mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 centimeters with a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. If your variable x is the height of a 15 to 18-year-old male from Chile in 2009 to 2010, then x is a variable that follows a normal distribution with a mean of 170 and a standard deviation of 6.28. First question, suppose that a 15 to 18-year-old male from Chile has a height of 176 centimeters, and they were also during the time frame of our study, which is 2009 to 2010. What is the z-score? So the z-score will be the value of the variable 176 minus the mean 170 divided by 6.28, and that is 6 divided by 6.28, which is approximately 0.96. I'm doing this in my calculator, on my phone, in Excel. The z-score tells us that the height of 176 centimeters is 0.96 standard deviations above the mean, to the right of the mean. So the question is asking us here in the parentheses, is it to the right or to the left? So since it's positive, it's going to be to the right of the mean. And the mean was 170 centimeters. Suppose that the height of a 15 to 18-year-old male from Chile from the time frame 2009 to 2010 has a z-score of -2. What is the male's height? So remember that to find the value of x, you will take the mean and you will add z times the standard deviation to find your x value. So if the mean was 170 and I add -2 times the standard deviation, which is 6.28, I'm going to find the value of x. So x will equal to 157.4. So the answer is, what's the male's height? 157.4 centimeters. The z-score of -2 tells us that the male's height is 2 standard deviations to the left of the mean because it is below the value of the mean. Negative is a direction on the axis to the left. Positive is a direction on the axis to the right. Last example for this video, from 1984 to 1985, the mean height of 15 to 18-year-old males from Chile was 172.36 centimeters with a standard deviation of 6.34 centimeters. If the variable y is the height of 15 to 18-year-old males in Chile in the period 1984 to 1985, then y follows a normal distribution that has a mean of 172.36 and a standard deviation of 6.34. According to the empirical rule, about 68% of these heights will be between the mean minus 1 standard deviation and the mean plus 1 standard deviation. So this is what has to go in this interval. So if I do 172.36 minus 6.34, the lowest bound will be 166.02. And if I do the mean, 172.36, and I add a standard deviation of 6.34, the upper bound will be 178.7. The z-scores for those heights are -1 to +1. So, right? So remember the units are centimeters here. This is the lower bound will be 166 centimeters. The upper bound will be 177.7. The 95%, again, remember the empirical rule, the 95% of these heights will be between the mean minus 2 standard deviations and the mean plus 2 standard deviations. So the lowest bound will be 172.36 minus 2 times 6.34. The upper bound will be 172.36, that's the mean, plus 2 times 6.34. So these values are 159.68 centimeters and 185.04 centimeters. (99.7% of those heights will be between the mean minus 3 standard deviations and the mean plus 3 standard deviations. So again, here I'm going to do 172.36 minus 3 times 6.34. That will be 153.34 centimeters. And the other value will be the mean plus 3 standard deviations, 191.38 centimeters. So, -1 to 1 standard deviation means -1 to 1 z-score. -2 to 2 standard deviations from the mean means from -2 z-score to +2 z-score. And -3 to 3 standard deviations from the mean will mean from -3 z-score to +3 z-score. Reminder for the glossary of this section, we talked about the empirical rule, also called the 68, 95, 99.7% rule, the standard normal distribution, which is the distribution of the z-scores. What is the z-score? You have the formula given to you in the midterm, so you don't need to memorize it. If you don't remember it, just reference the sheet. And what is the normal distribution? We will be using the normal distribution very often in the rest of the course, so you need to familiarize yourself with it.